Imagine walking into like a multi-million-dollar automated factory in 2026.
Right, just a massive industrial setup.
Yeah, exactly. You look past the giant robotic arms, you walk past the precision industrial cutters, and you open up the master control panel running the entire assembly line.
And what do you actually see in there?
Well, it's a $60 piece of green silicon.
Which is wild.
It really is. It's the exact same board you probably used to play, a laggy version of Minecraft on in middle school.
Yeah, a total tinkerer's toy back in the day.
But today, we're going on a deep dive into this massive, almost invisible technological transformation. Our mission is to understand how the humble Raspberry Pi evolved from this weekend novelty board into what our source material calls a post-scarcity computing substrate.
It is a remarkable evolution to track, honestly.
Oh, for sure. We're pulling all this from a phenomenal July 2026 article by Aaron Rose on tech-reader.blog. It's titled The Raspberry Pi in 2026, a scalable platform that retains its maker roots. And we're also pulling from some deep-cut technical insights from their blog archives.
Yeah, we are basically looking at a piece of hardware that fundamentally changed the trajectory of edge computing, but, without ever losing its original identity.
Right. And if you are listening to this right now, staring at like a $15 a month cloud storage bill, wondering why you are renting server space in a Nevada desert just to keep your family photos safe, this deep dive is going to totally change how you look at your own devices.
Absolutely, because if you're exhausted by the feeling that modern tech is fragile or disposable or just designed to extract a monthly fee from you, we're going to outline a radically different approach.
A much more human-centered approach to owning your digital life.
But to truly grasp how that cultural shift happened, we can't just talk about the philosophy of it.
No, you have to look at the hardware.
Exactly. We have to start with the physical silicon and look at the mechanics of what the hardware actually became by mid-2026.
Okay, let's unpack this, because the hardware leap is usually where the alphabet soup of technical jargon overwhelms people.
Yeah, it gets dense pretty fast.
It does. So the current generation anchoring this whole movement is the Raspberry Pi 5 alongside the Compute Module 4 and 5 family.
Right.
And Aaron Rose's article lists the specs, and they sound intense. We are looking at quad-core 64-bit CPUs, specifically the Cortex-A76, clocked at 2.4 gigahertz.
Which is plenty fast for most things.
Right, and it packs up to 8 GB of LPDDR4X RAM, plus it utilizes PCI lanes, supports NVMe boot drives, and has vastly improved graphics processing.
Yeah, but let's translate that out of the textbook jargon for a second.
Please do.
Take the RAM, for instance. That LPDDR4X is the exact same highly efficient, low-power memory you would find in a flagship smartphone.
Oh, interesting.
Yeah, so it means the board doesn't need some massive cooling tower just to keep from melting on your desk.
That makes a lot of sense. My analogy for this is kind of like the delivery industry.
Okay, how so?
Well, instead of building a massive gas-guzzling 18-wheeler, which is basically what a traditional cloud server is just to deliver a single pizza, the Pi is like an electric delivery bike.
Oh, that's a great way to put it.
Right. It is perfectly sized for the local job, and it draws an incredibly minimal amount of power. But looking at these specs, which match low-end desktop computers, did the Pi Foundation just decide to cram high-end brute force specs into a small board? Like, were they trying to steal market share from Apple or PC makers?
What's fascinating here is they actively avoided that trap.
Really?
Yeah, if you analyze the architecture of the Pi 5, it is a masterclass in engineering restraint. They did not chase raw brute force processing power just to win a meaningless benchmark war against a $1,000 laptop.
So what were they chasing instead?
Thermal efficiency and absolute reliability. Modern tech companies are obsessed with putting massive power-hungry GPUs in everything to run artificial intelligence.
Oh yeah, the AL hype train.
Exactly, and those chips draw hundreds of watts. They require dedicated cooling systems. But the Pi 5 uses an optimized ARM architecture.
Meaning what, exactly?
It relies on a streamlined instruction set, so it processes commands using significantly less electrical energy. It actually has the physical muscle to run what we call AI inference at the edge.
Which means it can run localized AI models.
Right, localized models, but it achieves this using a fraction of the electricity.
Okay, that makes sense mechanically.
Yeah.
But let's talk about the hard drive, because that was always like the Achilles heel of the old boards.
Oh, the old SD cards. It was rough.
It was. And the article makes a massive deal out of those PCIe lanes and the NVMe boot support. Back in the day, you had to run the entire operating system off a tiny micro SD card.
Which is a brilliant example of why understanding the physical mechanics actually matters.
How so?
Well, micro SD cards rely on a very basic type of flash memory. They were engineered for digital cameras, right? To save a photo every few minutes.
Oh, right. Not to run a whole computer.
Exactly. They were never designed for the constant, relentless read and write cycles of an operating system running background tasks 24 hours a day.
Yeah, the wear leveling algorithms on those little cards would just fail under the pressure.
Totally.
I remember the pain of that. You'd unplug the wall adapter without typing the proper shutdown command, and boom, the SD card would corrupt mid-write.
Your entire weekend project instantly bricked.
Yes. So how does an NVMe drive actually fix that physics problem?
Well, NVMe stands for Non-Volatile Memory Express. It is a completely different physical interface.
Okay.
Instead of routing data through a slow, bottlenecked SD card reader, PCIe lanes act like a multi-lane superhighway plugged directly into the brain of the computer.
Oh, wow.
And more importantly, NVMe drives have dedicated onboard controllers managing the flash memory. They distribute the wear and tear evenly across the silicon.
So it lasts way longer.
Exactly. An NVMe drive can handle operating system read-write cycles for a decade without degrading.
That's incredible.
Yeah, and that single kind of unsexy hardware change is what allows a factory manager to confidently trust a Raspberry Pi to monitor an assembly line without fearing a random memory crash.
That is huge. But upgrading the physical hardware and solving the storage bottleneck,
Yeah.
I mean, that created an entirely new problem, didn't it?
It did, yeah.
Because now that the Pi had the physical muscle and the durable storage to run for years, the heavy, bloated desktop operating systems of the modern era were holding it back.
Right, the software was too heavy.
Yeah. To make this tiny electric delivery bike shine, developers had to fundamentally strip down the software.
And this is where we see a massive cultural pivot. Because
Right.
the hardware deliberately limits its own power draw, the software ecosystem had to become incredibly optimized.
It transformed the Pi from just a piece of industrial hardware into a sort of digital sanctuary.
Beautifully said.
Thanks. The article highlights Raspberry Pi OS, which is a highly polished Debian-based environment.
Mm.
But I want to pull from that deep cut archive post you brought in.
Oh, the one about minimal operating systems.
Yeah. It compares Raspberry Pi OS Lite against a third-party option called Diet Pi. This is basically a showdown of minimal operating systems designed for headless servers.
Right. And for those listening, headless means there's no monitor attached, no mouse, no graphical user interface at all.
Just a tiny box sitting in a closet.
Exactly. You just talk to it through a command line interface from another computer.
So why is that important?
The mechanics of a headless server are vital here. A graphical user interface, the icons, the windows, the smooth animations on your screen, all of that consumes a massive amount of RAM and processing cycles just to render pixels.
Oh, just to make it look pretty.
Right. So when every megabyte of memory matters, stripping away the graphics frees up the computer to dedicate 100% of its resources to the actual task at hand.
Like routing network traffic or hosting a database.
Exactly.
So the archive article paints this brilliant dilemma. Do you go with the stable, widely supported comfort of Raspberry Pi OS Lite, or do you dive into Diet Pi, which takes this whole less is more philosophy to an extreme?
Yeah, Diet Pi strips out almost every background process until the system is just bone dry.
Right. They both promise a hyper-lean machine, but that level of hyperfixation on efficiency is what enables the broader cultural movement the main article discusses, the whole local-first computing rebellion.
Because the ecosystem gives you the exact tools needed to build a sovereign digital environment.
So what does this all mean? The article claims that, driven by rising cloud costs and privacy concerns, people want to host their own data.
And they are doing it.
Yeah, they're building home media servers, running personal AI assistants, managing complex smart home automation rules, all entirely locally. But let me push back on this narrative a bit.
Sure, go ahead.
Setting up a headless Linux server in a closet sounds like an absolute nightmare for the average person.
It definitely has a learning curve.
Right. So is this local-first movement just a digital off-grid fantasy for tech preppers who dream in command-line code? Or is there a practical reason for someone who just wants to, I don't know, listen to music and turn on their smart lights to care?
If we connect this to the bigger picture, the aha moment here isn't just about disconnecting from society.
Okay, what is it about?
It is about recognizing the economics of the modern technology industry. The tech monopolies realized years ago that they cannot sell you a new laptop every single year. So they changed the model.
Subscriptions.
Exactly. They started selling you the software on a monthly basis. You pay for a note-taking app, a cloud storage drive, a music streaming service, a home security camera subscription.
It's crazy.
It is a rent-seeker economy designed to trap you in perpetual microtransactions.
Death by $1,005 charges.
Precisely. And the practical benefit of the Pi ecosystem is that it breaks that cycle through long-term physical ownership.
Because the foundation actually supports the hardware for years.
Yes. The Pi Foundation ensures their software is supported long-term. You can install Diet Pi, deploy a self-hosted media server or a network-wide ad blocker today, and literally physically ignore it for half a decade.
And you own it outright.
You own the hardware. The data physically resides in your house. There is no subscription fee, no terms of service updates, and no company harvesting your habits to sell targeted ads.
It is the literal antidote to planned obsolescence.
It really is.
But taking back ownership of your data introduces a new kind of anxiety, doesn't it?
Oh, for sure. The hardware failure fear.
Yeah. If your entire digital life, your security cameras, your media, your smart thermostat, if all of that lives on one tiny $60 board in your closet, what happens if the dog trips over the power cord?
Or the power supply just simply dies.
Exactly. And this desire for local control inevitably led users to seek out the kind of bulletproof reliability historically reserved for massive corporate server farms.
Which leads us to the physical infrastructure shift. This is where the maturity of the software and the durability of the hardware perfectly intersect to create something entirely new.
Here's where it gets really interesting, because the Tech Reader article dives into the rise of the Raspberry Pi cluster.
Yeah, clustering.
Years ago, clustering Pis was basically a novelty. People would wire 5 of them together with blinking lights just to post a picture online and say, look, a tiny supercomputer.
Yeah, a fun weekend project, but not very practical.
Right. But by 2026, the article states, it is incredibly common to see a 4 to 8 node cluster quietly running a household or a small business.
Using it for distributed computing.
Exactly. Distributed computing, continuous deployment pipelines, and something called Edge Kubernetes.
Yeah, Kubernetes is a big deal here.
But I need to challenge this, though. Kubernetes is a complex container orchestration system used by global tech companies.
It is very complex, yes.
Using that to run a home server feels like using a sledgehammer to crack a peanut. Why on earth would anyone need a distributed enterprise system to keep their smart lights functioning?
Well, the sledgehammer analogy seems accurate until you look at the mechanics of failure.
Okay, explain that.
Let's define what Kubernetes actually does in this context. Imagine it as an incredibly fast, highly paranoid traffic cop standing in the center of your cluster of Raspberry Pis.
A paranoid traffic cop. I like that.
Its only job is to constantly monitor the health of those computers. If you are running everything on one machine, that is a single point of failure. The power supply dies and your house goes dark.
The cameras drop, the thermostat resets, literally everything breaks at once.
Exactly. But in a cluster, that traffic cop is watching. If board number 2 suddenly loses power or crashes, Kubernetes instantly, in a matter of milliseconds, reroutes the security camera software and the thermostat controls to boards 1, 3, and 4.
So the network never blinks.
Never. You build fault-tolerant systems at a micro scale.
The economics of that are completely wild to think about.
That is the secret right there. An entire cluster of 4 Raspberry Pi 5s with all their power supplies and networking cables is still significantly cheaper than purchasing a single mid-range consumer laptop.
Wow.
And because of the ARM architecture we discussed earlier, those 4 boards combined draw less electricity than a standard incandescent light bulb.
That's amazing.
You get enterprise-grade uptime without the enterprise-grade hardware cost. And without the deafening roar of industrial cooling fans.
Which is perfect for a closet in your house.
Yeah, exactly.
So you have this platform seamlessly running Kubernetes, hosting local AI models, and anchoring automated factory lines. Given that trajectory, I would expect the device to have morphed into a sterile, highly locked down corporate gray box.
Because that's what usually happens.
Right. Usually when a product matures into the enterprise space, it completely abandons the hobbyists who help test it. But the source text makes a point of highlighting that the Pi's massive success with IT professionals is explicitly tied to the fact that it never lost its maker soul.
The community is the beating heart of the platform, and the physical design of the board actually enforces that philosophy.
The article points directly to the GPIO pins as a cultural icon.
Yeah, GPIO.
Which stands for General Purpose Input Output. Mechanically, it is just two rows of exposed metal spikes sitting on the edge of the circuit board.
Super simple.
But they allow the computer to interface directly with raw electrical signals. You can wire up analog temperature sensors, physical motors, LED strips, or custom hardware attachments called HATs.
It literally makes computing tactile.
Yes, and the massive global community documents every single project so anyone can replicate it, which is why classroom adoption remains so high. It is a physical way to teach a student what a computer actually is, rather than just teaching them how to swipe on a slick, sealed glass interface.
The exposed pins force you to understand the cause and effect of raw electricity translating into digital data. It's brilliant.
But I struggle with this dual identity a bit. We are looking at one single computing canvas. Can a $60 board truly serve a distributed systems engineer deploying an edge cluster and a middle schooler writing their first Python script to spin a tiny motor?
It's hard to believe, I know.
Usually when a piece of technology tries to be everything to everyone, it dilutes the features so badly that it ends up being terrible at everything.
This raises an important question, really, about the narrative of technological progress.
How so?
We are constantly sold the idea that progress requires disruption. The tech industry teaches us that to create a professional, enterprise-grade tool, you have to lock the system down. You hide the exposed wires, seal it in impenetrable aluminum, and charge a massive premium for the privilege of using it.
Right, the walled garden approach.
Exactly. The Raspberry Pi proves that this kind of disruption is entirely optional.
So the secret was just not changing it.
The secret was consistency and extreme mechanical flexibility. By keeping the GPIO pins exposed and standardizing the physical footprint, they kept the barrier to entry low.
Okay, I see.
Mechanically speaking, a 12-year-old triggering a motor and a systems engineer routing factory data are executing the exact same process.
Oh.
They are taking raw inputs, processing them through a CPU, and generating outputs.
That's a great point.
The Pi doesn't water down the experience for either of them because it is fundamentally just a capable, entirely open canvas. In an era where consumer devices are sealed, disposable, and designed to funnel you into subscriptions, the Pi is defiantly frugal.
Defiantly frugal.
It is an unapologetically human-centered tool.
I love that phrase, defiantly frugal. It perfectly captures the journey we have unpacked today. Let's recap this incredible arc. We started way back in 2012 with a humble, inexpensive circuit board that was mostly famous for blinking tiny lights and occasionally corrupting its own SD card if you unplugged it too fast.
A fascinating but very fragile educational stepping stone.
Yeah. And over 14 years, it completely bypassed the flashy benchmark wars. It used slow, relentless mechanical refinement, moving to efficient smartphone memory, adopting NVMe storage, optimizing minimal software, all to become a mature computing substrate.
It's wild to see.
It evolved into a device capable of anchoring the local-first software rebellion, allowing people to reclaim their data from cloud rent seekers. We are seeing users build silent shoebox supercomputers in their closets, deploying enterprise traffic cops like Kubernetes to ensure their smart homes never go offline.
Yet through all of that industrial scale, it kept the exposed metal pins.
It did.
It kept the open documentation. It continues to teach the next generation how the physical mechanics of computing actually function.
If you are listening to this, understanding the Raspberry Pi ecosystem in 2026 is so much more than just learning some trivia about a cool circuit board. It gives you a literal blueprint for reclaiming your digital autonomy.
Completely.
It proves that you can run your household, protect your data, and manage your network on your own terms. You do not have to accept the endless churn of fragile lockdown devices. You have the power to build something durable, reliable, and entirely yours, bypassing the tech monopolies altogether.
It reminds us that at its core, hardware should be a tool that serves the user, rather than a Trojan horse to extract continuous revenue.
That is the ultimate takeaway. As we wrap up this deep dive, I want to leave you with a thought to mull over on your own. We have just explored how a cheap, exposed piece of hardware quietly scaled up to replace expensive cloud infrastructure and teach a generation the physics of computing.
It really makes you wonder.
It does. What other frugal, incredibly basic tools are hiding in plain sight right now? What other humble, overlooked technologies are out there quietly being refined, just waiting to dismantle the next massive tech monopoly? Think about it.